VR technology is becoming more common, and that brings on constructing various kinds of VR system. Therefore, the needs to connect these different virtual environments over networks are continuously increasing in order to work and communicate in a single space. For this, we have built a PC-based cave-like system for the first time in Korea, and researched the construction of a shared immersive VR environment connecting the virtual table, projection wall, and cave system. We developed a novel, low-cost method for visual communication and telepresence in a cave-like environment, relying on 2D stereo-based video avatars. Our user mirroring system combines a selection of proven, efficient algorithms and approximations in a unique way, resulting in a convincing stereoscopic real-time representation of a remote user, acquired in a spatially immersive display. The system was designed to extend existing projection systems with acquisition capabilities requiring minimal hardware modifications and cost. Alice in Virtual World is a network VR game which runs on a multiple-device compound virtual environment which is synchronized with virtual table, projection wall, and cave-like system. This technology enables people to play the game in different locations with various immersive displays and interaction devices to interact with virtual objects. Alice in Virtual World was exhibited in ACM SIGGRAPH 2003 and attracted much attention with its originality in connecting 3 different virtual environments. Human-centered mixed reality. The core of future digital life is to make human surroundings smart. We research human-centered mixed reality to support people's free behaviors in daily life. An environment with object recognition by sensors can identify individuals dynamically and provide personalized services. Moreover, we developed a projection-based display for users to move, scale, and rotate freely. With this technology, a person can put the displayed image on a wall or ceiling easily with a wireless controller, as well as modify the direction of the display to see from the person's viewpoint, which avoids the user having to move onto the axis of projection in order to see an undistorted image. Our smart environment research has been done not only indoors, but also in automobiles, which are one of the most essential machines for human beings. The User Adaptive Digital Instrument Cluster is a personalized driver interface using digital flat displays and mobile devices in cars. This system can display the car's current condition effectively in various graphical ways and allows drivers to have their own dashboard design and modify it freely. This novel technology was awarded Grand Prize in Hyundai Motors Auto Mechanical Design Contest in 2005, and it is now an application for Korea patent. As projector hardware improves at a dramatic rate, we have given considerable attention to developing novel techniques and applications for smart mobile projection. We built a multi-resolution large display to improve the quality of large displayed images using a mobile projector. A mobile projector can be used not only to improve the brightness and resolution of the region of interest in an image, but also to provide additional information. Existing techniques require a large-scale physical apparatus to track the mobile display, but we make it very simple by using a camera attached to the mobile projector and a frame-shaped marker embedded in the large image. By constraint-based updating of the marker, we can determine the position of the mobile projector and generate an appropriately warped version of the inset image in real time. Another good match for the mobile projector is the smartphone. To alleviate the cognitive effort in wayfinding with maps, we project direction arrow images on planar surfaces by using a mobile projector coupled with a smartphone. Given a path and waypoints for any destination using GPS and digital map database, we calculate 3D orientation of the projector using the gyroscope and digital compass of the smartphone. Then we determine the projection transformation to warp the projected image. We can get consistent images without shape distortion on many surfaces. The proposed prototype, in cooperation with computer graphics group of RWTH Aachen University, can achieve better navigation performance by providing a conventional 2D map on the smartphone screen, as well as directions directly visualized on the floor surface. To predict performance of underwater vehicles, for instance submarines, torpedoes, and unmanned submarines, in military simulations, we developed a visualization system that could help verification of digital mock-ups and simulation of underwater vehicles using virtual reality-based 3D visualization and interaction techniques. The visualization system could provide situation awareness for simulated 3D military environment intuitively, by visualizing an overview of the battlefield as well as a detailed view of a user-selected entity. In addition, the proposed gesture interface for a 3D large-scale display allows its users to manipulate the 3D view by hand gestures without any input devices. This work has been performed in partnership with Seoul National University and Korea Aerospace University, as a project of Research Division of Underwater Vehicle Research Center, established at Korea Maritime University by the Defense Acquisition Program Administration. There has continuously been a demand for virtual characters known as avatars, which resemble users' faces in many games and online chatting. To meet this demand, we are developing a 3D facial model reconstruction technique based on user's face. At first, we obtain 3D facial data based on users' faces by using a depth sensor to detect feature points of the faces and to reconstruct 3D faces that are similar to actual faces by using 3D morphable face model fitting. We are developing technology that can produce natural face expression animation by real-time tracking of face characteristics based on new face models.